Hope this works. It's been a while. So brand new for this year. Or not new, but a little bit worded differently from last year. So I'll put up a new video. We're still talking about domain and range. I give you this handy, possibly handy table to help you remember domain and range. So they give you this little mnemonic, and so we're just going to fill in some of the words here. So D is domain, right? Or I, your domain is just another word for your input of your function, and then the X stands for your X values or X coordinates, depending on how you want to think about it. And then our definition of domain is a set of all possible X values. Okay, that's our superficial definition of domain. Set of all possible X values, all possible inputs. And on the other side is just range. So R, of course, is range. O to the opposite of input is output. So everything that comes out of your function is the range. And then Y just stands for Y values or Y coordinates. Okay. And then definition of range, as you probably guessed, is just a set of all possible Y values. Okay, so there's some notes, you copy that down. Hopefully it'll help you out. All right, but our goal for today is to actually write out domain and range in different situations. So the first couple are kind of easy, just tables and sets of points. So we just say domain. We put, 2 dots. And then we're just going to list out all of our unique X values. So if you want to make a set of numbers, we use our little curly braces. And then in order from least to greatest, we just list out all of our unique X values. So there's our domain, 1, 2, 3. Nice and simple. And then we do the same thing for range. Range, dot, dot, curly brace. And then these are also in order, so that's nice. Usually the range is not in order from least to greatest. You got to do a little bit of thinking. But there you go. So I just wrote down all my different X values, that's my domain. All my different Y values, that's range, I'm done. Simple. Okay. Our second one, just a set of points. Same idea, right? So domain, dot, dot, curly brace. So remember, in ordered pairs, the X values come first. So the smallest one up here is 0.4. I'm just going to put 0.4, so kind of lazy. Even though there's 2 of them, I'm not going to write them both down, right? We said unique X values. So if you already have 0.4, you don't have to put it. You don't have to put it again. So the next highest is 0.5, and then our biggest is 3.1. Close our braces. And we could also say, if you remember from yesterday, since that 0.4 repeats, this is not a function. That's okay. All I care about is domain and range. So range, braces. This time I look at my Y values. So from least to greatest, this is just backwards. This is just going to go 0, 1, 2, 3, and 4. Okay? So that's not too bad. If it just gives you points, you just list out all the unique values, preferably in order from least to greatest. Okay. Where it gets a little bit more involved is if they give you a graph. Okay. So we are going to look at this using inequalities. There's actually 3 different ways we can show the domain and range here. Each day we're going to look at one of them. We're going to start off with inequalities. So if I start with my domain, that's all my possible X values, right? So if I look, it's going on forever, and it looks like it's getting steep, but since it's at any kind of angle here, we see it going outwards. So if this goes long enough, right, this will go on forever along our x value, right? So as long as you see the arrows, we know that goes on forever, which means the smallest possible x value is not at negative whatever 3 or 4. You got to think big. If this, we extended this graph out forever, okay? So our domain can be any real number. So to show that with an inequality, what we do is we put x in the middle, and we put, let me make sure I get my signs going the right way here, which I didn't. Oh well. Do that again. Right? X in the middle, inequality. So the smallest possible x value, we'd say, is at negative infinity. Right? It isn't really a number, it's just more of an idea, right? That this goes on forever all the way to the left, negative infinity. And on the other side, hopefully you picked up on this. This is going to be positive infinity. Okay, so if our domain is all real numbers and we want to write it as an inequality, that's what it's going to look like. Okay, negative infinity less than x less than positive infinity. Okay, and then our range is not quite that simple. So two ways we could do range. So first off, we look, remember ranges are y values, and we definitely have a minimum here. If you remember from last year, the parabolas, minimums. So I know that the lowest possible y value is at negative 1. So I can say that y must be greater than or equal to, right? Because there's definitely a point at negative 1. I can say negative 1. Okay. We could also set it up sort of like how we did this one. So it's definitely, y is going all the way up. So on this side we'd have positive infinity. But on the other side, we said there's a minimum. So it doesn't go all the way to negative infinity. It stops at negative 1. And then we put our little equal sign. Okay. I would stick with this one because it's less work, it's less thinking, and it looks better, right? So really only put the infinities if it's all real numbers, and you need both sides. Okay. All right. What about something that doesn't quite go on forever? How about our little circle here? We'd say our domain. So I'm only looking, remember, domain left to right, yeah? So my point furthest to the left is right here at x is 0. And then my furthest to the right is over here at, if I count this off, 1, 2, 3, 4, right? So my circle exists between 0 and 4. So again, we would put x, and then I always have to remember how to write these for some reason. So we say x is greater than 0, or actually it's greater than or equal to, since there's definitely a point here at 0, right? And on the other side, it has to be less than or equal to the 4, okay? So anytime you have a closed off figure, you gotta look, what's the point furthest to the left? What's the point furthest to the right? And then that is going to be our domain. And then we do the same thing for range, only instead of going left to right, now we're looking at it from top to bottom or bottom to top. Fortunately, on a circle, circles are kind of nice in that they're even like that. So my lowest point is where y is 0, and my highest point is where y is 4. So we actually get the same answer for both, and that y less than or equal to, and then a 0 and a 4. Okay, so that's all we're doing for these, is we're just looking what's my leftmost point, my rightmost point, and then range, lowest, highest point, write out an inequality, and you get 100. All right, let me know if you have any questions. Good luck.